So there is a sum which is saying that find 2 to the power 4 by 1 plus I to the power 2k plus 1 plus I to the power 2k by 2 to the power 4, depending upon k whether it is odd or even. So this is a complex number sum. You know, complex numbers are very difficult to solve, but as you practice it becomes easier and easier. So here is the solution. What we need to do first is, we can see that it is given that find the values of k, means find the values of this expression depending upon whether k is odd or even. So first let's solve this expression. What we can do is 2 to the power 4. Now we can write this like this, 2 into k, right? Now this one also has 2 into k by 2 to the power 4. Now this is 1 square plus 2i plus I square, which is a square plus 2b plus b square, into there is k, means to the power k. Here also the same thing. Okay, now we know that I square is equals to minus 1. So this and this gets cancelled, this and this gets cancelled because they are both 1s. This 1 is a minus 1. Okay, I hope you can see properly. Now what we're going to do is, this is given 2i to the power k, and this is also given 2i to the power k by 2 to the power 4, right? Now this one, 2 to the power k into I to the power k plus 2 to the power k into I to the power k by 2 to the power 4. 2 to the power 4 minus k, because this power is means in the denominator, I to the power k, plus this will go to the denominator for 4 minus k. Now we cannot take this LCM, I to the power k. Now see this, what we get when we divide this we get. Okay, now 2 to the power 4 minus k square plus this, then we get this square, right? Now we do is 2 to the power plus we get is I to k, 4 minus k dot I k. Okay, now we're going to divide this. See, this is the expression we get, right? This is the expression we get now. K can be 1, 3, 5, 7, dot 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 dot. Let us find out 2. This is okay. Whatever k is here, it won't matter, but here it will matter a lot. Here it is k. So I square is always minus 1 to the power k. K is always an odd power, or 3 or 5 or 7 or 9. Every odd power it will give minus 1 only. Okay, so this will always have the value minus 1 in case of odd numbers, but in case of this, the downward I, it will differ, because 1 to the power 1 is I to the power 3 is minus I to the power 5 is again I to the power 5 is what? I to the power 3, I to the power 2. What is I to the power 3 minus I? What is I to the power 2? I to the power 2 is minus 1, as I wrote here before, minus 1, right? So this will be again I to the power 7. This will be again minus I. So this is changing, right? Like for 1, 5 it is again this, then for 5, 9 it is this. So it will change depending on what it is, right? So what you're going to write is that for k equals to 1, 5 means 1, 3, 5, 7, 9, 1, 5, 9, 11, not 11, 11, 13, yes, 13, the values means the expression's value will be this. What is the expression? 8 minus 2k to the power 8 minus 2k plus I square k. This will remain same no matter what number it is. Then on the downward side, what do we have? To the power 4 minus 2 into I. In case of the 1, 5, 9, 13, what do we get? We get only I. So this value will be only I. Okay? It doesn't matter what it is. And we can also write it like this. Because it will always remain minus 1. So k also now need to be written 4 minus k into n. Done. But again, when for k equals to 3, 7, 11, we're going to get minus I. I also write minus 1 only. Minus. Okay. I put this minus I in front. Now for even numbers. For k equals to 2, 4, 6, 8. If k is a multiple of 4, this is alpha, okay? It's just a multiple of 4. So if it's a multiple of 4, like this one, okay, then we're going to solve only this part, okay? This won't matter because I squared to the power k, if it is minus 1, then minus 1's power any even power 2 or 4 or 6, it will always give 1. So I only bothered with the I to the power k power part. Now for the I to the power k power part, what will happen is, if it is I square, it is minus 1. I to the power 4, I square to I square, it will minus 1 into minus 1, which will be plus 1. 6 into power 4, so it is 1 into minus 1, it is minus 1. And again I to the power 8, it will be plus 1. Then I to the power 10, it will be minus 1. Just like that, I to the power 12, it will be plus 1. So it's alternate, right? But this is minus 1, plus 1, minus 1, plus 1, minus 1, plus 1. It's alternate. So we need to again make cases. For case 1, just like we did in the odd case. For case 1, for k equals to 2, 6, 2, 6, then we have 10, tolerate. The value will be 2, it will is 2k, plus, it will always be 1, right? You know that. For minus k into, in case of 2 and 6 and 10, it is minus 1. So put this minus forward and just make this one disappear. Okay, now 4k equals to 4, 8, 12, like what are these numbers? These are, sorry, not this, these are the multiples of 4, right? And what are these numbers? Right? Plus 4 into 1 plus 2 gives 6. 4 into 2 plus 2 gives 10. 4 into 3 plus 2, 14. After 12, we get 14, right? Which will again give us minus 1. So, these are the numbers. And if we put 0, 4 into 0 plus 2, we get 2. So, these numbers are actually 4 into something plus 2 is 4 into natural number plus 2. So, this is a directly multiple of 2 or is directly a multiple of 4. Well, this is a multiple of 4, but with a remainder 2. this is the answer. 1 will be there, and this will be 4 minus k only, because in 2 it's 1, because I to the power 4 always gives 1, I to the power 8 always gives 1. Okay, the final answer for the first odd case, it was to the power 8 minus 2k plus minus 1, 4 minus k I. For second odd, 2 to the power 8 minus 2k minus 1 minus 4 minus k I. For the case 1 of even, plus what guys? 2 to the power 8 minus 2k plus 1. Okay. Case 2 odd, 8 minus 2k plus 1 to the power 4 minus k into 1. So these are the answers. You can see it all at once. So please like, subscribe and share my videos, and also subscribe. Okay, so if you have any difficulties, please write in the comment section what I have to improve and all. And if you want more videos on different types of sums, please tell me, because these are very important sums and you need to understand these, because complex number is a very important chapter, is a crucial part of mathematics for class 11 and 12 and for JEE and NEET syllabus. I mean, not for NEET syllabus, means people who have taken up maths but are still giving NEET and JEE together. Okay, so best of luck for your future, and thank you so much.